All right, so to measure the basal metabolic rate of the rat in the classic way, we have our chamber, which is this device right here, sealed and connected to an improvised manometer. We will put in our rat into the chamber. Thank you. Get your tail in. Okay. So now we have the rat, and we start the timer. So now the rat's in the sealed chamber, breathing, consuming oxygen. The small pot that has gauze wrapped around it has soda lime in it. That will absorb the CO2 that the rat evolves. Thus, there'll be a net reduction in air pressure as the oxygen is consumed. All right, at 5 minutes, 23 seconds, we are at the 20 mil consumption calibration mark. So after 5 minutes, 23 seconds, 20 mils of oxygen were consumed by this rat. Our next calibration mark, in fact, the end of the experiment, will be the 30 mil mark. That represents 30 mils of oxygen consumed. And again, to reiterate, as the rat is breathing and consuming oxygen, the CO2 that's being evolved is being absorbed by the soda lime, which is contained in this canister wrapped in gauze. So there's a net reduction in air pressure as oxygen is consumed. We're coming up on our 30 mil point right there. We've just passed it. 7 minutes. At the 7-minute mark, this rat consumed 30 mils of oxygen. We have determined that 30 mils of oxygen were consumed in 7 minutes. In order to calculate the metabolic rate, we now need to know the weight of the rat. So we will determine the weight of the rat as the next step. So this rat weighs approximately 229 grams. We determined that the weight of the rat was 229 grams. Previously, we determined that 30 mils of oxygen were consumed in 7 minutes. We then determined that per hour, that is 257.14 mils of oxygen per hour, which gives us a metabolic rate of 1,122.88 mils of oxygen per kilogram per hour.